In this video, I want to talk about similarities and differences between scalar line integrals and vector line integrals. So both scalar line integrals and vector line integrals, I wrote an example, a generic looking one here on the left side down here. They both are integrating over some curve C. And the first step of these problems, if you aren't explicitly given a curve C, your first step really should be to write down a parametrization R of t. T runs from A to B for your curve. And because in both of them, the way we actually compute them on the right here will be integrating from A to B, integrating from A to B here, stuff like that. And another important similarity is that both scalar line integrals and vector line integrals give you scalar output. So something we should always be thinking about is what type of answer are we getting to problems? Are we getting a scalar answer? Are we getting a vector answer? Stuff like that. And so in a scalar line integral, we are integrating a scalar valued function over a curve. And this over here, this expression here will give you a scalar output. This looks complicated, but this just ends up being, this is a function of t, this is a function of t, the product is a function of t. You're just integrating a function t from a to b dt. This is a, straightforward integral from the end of Calc 1. But in the vector line integral, the function that we're integrating, this f of x, y, z, this is a vector valued function. This needs to depend on f. This is, and the term we introduce here in the section is this is a vector field. But even though we're integrating, the original thing that we're integrating here is a vector, there's a dot product in the calculation. So take a look over here on the right side. F of r of t, this is a vector object. R prime of t, this is also a vector object. But when we take the dot product of these together, this is a scalar down here. So this entire quantity is a scalar. So when we're integrating from a to b, the scalar dt, we do end up with a scalar output. Okay, so that's an important similarity. You might think that, this gives a scalar output, this gives a vector output. The vector line integrals give us scalar outputs as well. So computationally speaking, in both of these, we take our parametrization and substitute it into the integrand here, little f of r of t, big F of r of t here. And then we need to multiply by the derivative of our parametrization. And so the thing to realize here is, one important difference is, what do we mean by multiply by the derivative of the parametrization? Well, in the scalar line integral, we can't just multiply by the derivative. We can't just multiply by r prime of t because that would be the wrong type of object. We have to multiply by the magnitude r prime of t. And then down here, we need to multiply f of rt by r prime of t, but those are both vector objects. So when we talk about multiplication, we need to be specific. What do we mean by multiply? We mean the dot product. So these look similar, but scalar ones we multiply by the magnitude r prime of t. Down here we do a dot product with r prime of t. So make sure you get those two things straight. Honestly, the dot product is often easier computationally to work with. One more important thing that is a difference here is that for scalar line integrals, direction doesn't matter. So if, here is your curve C here, it doesn't matter whether you're going from here to here or from here to here, you'd get the same answer. However, in vector line integrals, the direction does matter. So if you integrate along this way for c, you get a different answer if you integrate going in the other direction. And in fact, the integral along here is equal to the negative of the integral along here. So that is one more important difference between scalar and vector line integrals. Also, it is worth saying that vector line integrals are the more important tool for us computationally. First off, there's more applications of vector line integrals, and also in many of the sections from here to the end of the book, we're going to be doing more vector line integrals. We won't be doing too many more scalar line integrals.